Hi everyone, I will talk about transaction processing. Overview is introduction to transaction processing, transaction and system concepts, desirable property of transaction, scheduled transaction, characterizing schedule based on recoverable, characterizing schedule based on serializable. At the start, if I have a single user system, there is one user access my database at certain time, and when he or she finish, the transaction is the second user access my database because a single user system, but in multi-user system, the situation is different because I need another system, that concurrency system, that control the overlapping between different user, between different transaction. So concurrency, we could have two methods in the processing where I have a number of users, but I have one CPU interleaved processing, so I need to make sure that they are processed a right way or parallel processing. There are more complicated number of transactions are done at the same time and how they are overlapped. What is the transaction? A database is logical unit of database processing that include one or more access operation. So for a user, if he or she want to access my database, he want to read A, multiply A by 3 and write A. This is a process. This is transaction whereas is a start and end with number of operation inside it. A transaction is a set of operations, read, write, commit, whatever may be written in high-level language, SQL, or it could be embedded inside a program, but the main purpose is to access to my data, either read or write or any other operation. So this is transaction. A transaction always have beginning and end is a commit where the transaction terminates, and it is a very important operation. A transaction, if I have a program, it could have a large number of transactions that allows it to access my database, and it separates different transactions by beginning and end, and also it can, application program, it can mean manage which one starts before or with the other transaction. There is a terminology called granularity, which means the size of data but not the number of fields or number of records. It's not the disk size, no, it is the size of data, and we will see why we need it, because the transaction is not related to granularity. It is different, doesn't care about size of my data. It is about the process. So in a transaction, there is a basic operations. They read where it try to access my data and copy the data to be used within the transaction. Write item, if I do change that, the data, then transaction asks the database to write that data back to database system.
Read and write operation. Read item X. Command include the following steps. Find the address of the disk block that contain item X. Then copy the disk block into a buffer in main memory if that disk block is not already in some main memory buffer. Copy item X from the buffer to the program variable named X. Write item X. Command include the following steps. Find the address of the disk block that contain item X, then copy that disk block into a buffer in main memory if that disk block is not already in some main memory buffer. Copy item X from the program variable named X into its correct location in the buffer. Store the updated block from the buffer back to disk either immediately or at some later point in time. Read and write operation working with buffer and blocks. The database management system will maintain in the database cache a number of data buffers in main memory. Each buffer typically hold the contents of one database disk block, which contains some of the database item being processed. When these buffers are all copied, and additional database disk block must be copied into memory. Some buffer replacement policy is used to choose which of the current copied buffers to be replaced. Some commonly used buffer replacement policies are LRU, least recently used.
The example, I have transaction 1 and transaction 2. Transaction 1, it will read X, then it will subtract N from X, then write X, read Y, then add N to Y, then write item Y. The transaction 2, read X and add M to X, then write X again. Two simple transactions that occur in my database.
Concurrency control is needed. One of them, the lost update problem. This occurs when two transactions that access the same database item have their operations interleaved in a way make that value of some database item incorrect. For example, when we have two transactions, transaction 1 read item X, then do change X minus N, then transaction 2 read the old value of X, then do change X plus M, then do update in transaction 1. We lose this operation. Updated item X, write item X, then read item Y, then write item X, write item Y. This will be losed incorrect value because it's updated by transaction 1 is losed this one.
Transaction, read the data, then update the data. Second transaction, read the new data, then update the data. But for certain reason, transaction 1 failed. What will happen? Concurrency control will undo that transaction. It will go to the log file and see what was the previous value of X, and it will write it again. But transaction 2 does not know about that. This is called dirty read.
The other problem is incorrect summary problem. If one transaction is calculated an aggregate summary function on number of records while other transactions are updating some of these records, the aggregate function might calculate some value before they are updated and others after they are updated. As we see in this example, T3 reads X after N is subtracted and reads Y before N is added. A wrong summary is a result. So this is why we call it incorrect summary problem.
Unrepeatable read problem. A transaction T reads the same item twice and the item is changed by another transaction between the two reads. A transaction receives different values for its two reads of the same item. At transaction 1, read the item X, add in value to X, then it write the item X to database. After that, at transaction 2, read the item X, add in value to X, then write the item X into database. Now, when the transaction 1 read the item X, the value of X will be different of the value that's written into X in a previous operation of the same transaction.
Why recovery is needed? The database management system is responsible for making sure the operations are either completed successfully, transaction committed, or transaction does not have any effect on the data, on the database or any other transaction aborted. The second thing is transaction has to execute all of the operations or none of the operations. So basically the transaction execute or it will not be executed. There will not be a case when half of the operations are executed. Reason of failure. A computer failure, system crash. During the transaction, at certain point, the computer fails due to a number of reasons. Maybe it's a power failure, network failure, or some internal errors. A transaction or system error, for example, something divided by zero. Local errors or exception condition detected by the transaction. Like number is unavailable or equal to null. Concurrency control enforcement. Multi-transaction are executing together. These transactions are also cause a deadlock. If there is a deadlock, one of the transaction has to be aborted. Disk failure means that the system is not able to read the disk correctly, so this disk has failed and it's not working correctly. We can solve it by buying a new disk or replacing the hard disk. Physical problem. Whole system is destroyed due to some external issue. The recovery managers keeps track of the following operations, being transaction, when you start the transaction and execute it. Read and write, these are some of the operations for the database. And the transaction, the specific that read and write transaction operation have ended and marks the end limit of transaction execution. There is a commit transaction, which is mean the ended successfully, and rollback or abort, which mean ended unsuccessfully.
Okay, so the transactions states, or the diagram that shows the state of the transaction is here. The first we begin with this transaction. It gets affected by it gets active by writing and reading the process, and then it ends with partially committed and then abort, or directly aborted. And the result of aborting is always the transaction fail. Then if we complete it with the partially committed, it will complete committing, then its state will be committed and then terminated. So the termination state could be committed and aborted. The system log, the log keeps track of all transaction operations that affects the values of database items. The log is needed to permit recovery from transaction failure. Because the log is in the disk, so it could not be filled by any failure except the disk failure. And the log is periodically backed up to archival storage, which is tape, to guard against such catastrophic failures. Here's the system log. Here's the types of log records. The first one is start transaction. Then you write the transaction ID, which is generated automatically by the system. The other one is write item T and X and the old value, then the new value. Then the other one is read item and the transaction ID and then X. The other one is commit and the transaction ID, The last one is aborted transaction ID.
How to recover from the system log. Because all the records of the write operations exist in the log, we can undo the effect of those write operations of the transaction by tracing forward through the log and reset the old value for each item. And if a failure occurs while doing the commit or after the commit, the system log not sure if the effects of the transaction written into database or not, then the system will need to redo all the work of the operations. Uh, it's uh, it's redo the work by tracing forward through the log and set the new value for each item. Commit point for transaction. If all transactions uh, that apply the operations and that operation have been executed successfully, and all effect of this transaction also recorded into the log, the transaction will reach the commit point, and it will write an entry commit transaction into the log. When a transaction started by the system log and something happened cause the transaction to finish without doing the comment, or the system need to roll back the transaction by undo all the effects of the transaction operation of the database. So it's needed for transaction that have been start transaction entry into the log, but no comment entry. Redoing transaction. Transaction that have written their commit entry into the log must have recorded all write operations in the log. Otherwise, their effects on the database redone from the log entry. At the time of system crash, only the log entries that have been written back to the disk considered in the recovery process because the content of main memory may be lost. The first writing for a log, before a transaction reach its comment point, any portion of the log that has not been written in the disk yet must now return to the disk.
These are the four desirable properties of a transaction. ACID properties. The first one is atomicity. A transaction is an atomic unit of processing. It's either performed in its entirety or not performed at all. The second one is consistency preservation. A correct execution of a transaction must take the database from one constant state to another. The third one is isolation. A transaction should not make its updates visible to other transactions until it's committed. This property, when enforced strictly, solves the temporary update problem. The fourth one is durability or permanency. Once a transaction changes the database and the changes are committed, these changes must never be lost because of the subsequent failure.